There are three properties with logarithms that we're going to take a look at today. So we first have our multiplication property. This says that if you have log of a base and you're multiplying two things together, it can also be written as log base b of x plus log base b of y. So you take the two things in the argument that are being multiplied, you split it into two logs and put a plus in between. We have the quotient property, so your argument has two things being divided. So you're going to split it to two logs and subtract between the two logs. So then we have the power property, which is if you have an exponent in the argument, you can also write it as the exponent being multiplied out in front of the log. Okay. Now I like to help myself remember this because you can make a cross with your arms for multiply, and then if you tilt it sideways, you can make a plus sign. So if you're multiplying in the argument, it goes to adding two logs separately. If you're dividing, so you can make a slash, not that way, the other way, slash for dividing, and then turn it sideways, that gives you a subtract. So divide goes with subtract. And then you can take your hands and put them as fists and do a power to a power, or representing something to a power gets multiplied, so you put the two fists together so that you create just a one dot, which is multiplying. So your power goes out in front to multiplying. Okay? So what we can do is we can use these properties to what we call expand or condense. So you can write it into multiple logs, or if it's written in multiple logs, you can write it down into one log. So for example, we're going to start with condensing first. So notice here we've got two logs that are being added. Well, if we think of adding, we put a plus sign with our arms and then turn it sideways. That gives us multiplying. So this can be written as one log. Remember, condense means one log, right? You're condensing it down to a smaller amount. Okay, so log base 4 of 2 times x. So you take these two things, the arguments, and you multiply them together. Okay? There's no simplification beyond that I can do, so then I'm all done. If I look at this one, these two are being added, so when you have adding, you put a plus sign with your arms, you tilt it sideways, and that gives you multiply. So we're going to have log base 3 of pq. So we're taking the arguments and we're multiplying them together. On this one, instead of a plus, we have a subtract. So our subtract, if you have your arm out as a subtract sign, you can tilt it sideways to make a divide. So you're going to condense it down to one log, and you're going to divide the two arguments. So you're going to do the z divided by the y. Wow, that's not what I was trying to do. Okay. So then we get log base 5 of z divided by y. Now notice here that both of these, and all three of these examples actually, all of them have the same base. So this only works when your base is the same. If the base is not the same, then you cannot do that, and there's not any simplification that you can have with it. Okay? So if we look at the next one, we have log base 2 of 6 minus log base 2 of 3. So subtract goes with divide. So we're going to divide the arguments. So 6 divided by 3. And it's log base 2. But we can simplify 6 divided by 3 to be 2. So log base 2 of 2. Well, remember we have the property, if it's the same base and the same argument, that simplifies to 1. Or you can think 2 to what power equals 2. Well, that means that the x value is 1. So this just simplifies down to 1. Okay. If we have something being multiplied out in front, it can turn into a power. So this is log x squared. Now remember, there's no base here, which means it's an unsaid 10. So just keep that in mind. But if you're multiplying out in front, it can be moved to a power. So you have your two fists put together to make a dot, and then you raise one to the power, and that's how you can remember that one. Okay. Now this, you have to be careful on this one. This can be written like it is, or it could also be written as 1/3 natural log 4. So notice the 1/3 is kind of embedded here, but that still is being multiplied out in front, which means that it can be a power. So I can do the natural log of 4 to the 1/3. Well, hopefully you remember from previous years that we have roots or this can be written as a root when it's a fractional power. So you had this property here, that if you had a to the n over m, it was the same thing as the mth root of a to the n. So the numerator went to the power, the denominator went to what kind of root it is. So here, if you get a fractional power, I want you to switch it to a root. So this will be the natural log of the cube root of 4 to the first power, but I don't need to write the first power. So then this is our answer here. There's not any other simplification that we can do here, right? You should be checking like on this one where we could simplify and then we could evaluate it. So we could simplify the dividing and then we could evaluate this to make sure that there's not any other simplification you can do. Now, those were all of them individually, but now we can combine multiple of those properties. So for example, this has both numbers in front and 2 logs being added. So the numbers in front go to the powers. So I can write this as log base 3 of x squared plus log base 3 of y to the 6th. But when we have 2 logs being added, we can combine it or condense it down to 1 log. And adding goes with multiplying, where you have your plus sign with your arms and you tilt it sideways to get to multiply. So x squared times y to the 6th. Okay. So this is our final answer. There's no other simplification I can do with this. I have no fractional exponents, so I didn't need to change anything to roots. So that's our final answer. Okay. Now here we've got multiple ones. We've got 3 of them here. So I'm going to move these to powers. Okay. So this goes to a power here, this goes to a power here, and then this is an unsaid 1, so I don't need to worry about it. So we have log base 5 of m plus log base 5, m to the 3rd, sorry, I dropped my power, let's not do that. Log base 5 of n to the 2/3 minus log base 5 of q. Okay. So if I look at these 2 things here first, these 2 things are being multiplied. So that means, they're being added, which means I can move it to multiplying. So log base 5 of m cubed n to the 2/3. So we took these 2 things and we multiplied the arguments. But I still have minus the log base 5 of q. So when we're subtracting logs, that means that you're dividing the arguments. So this argument divided by this argument. So I'm going to take this thing here. So log base 5 of m cubed n to the 2/3. And then divide by our argument of this one, which is divided by q. So then this is my answer. Notice I've got a fractional power, which means that I can change that to a root. So this will be log base 5 of m cubed cube root of n squared over q. Okay. So I switched my fractional power. There's no other simplifying I can do with any of the exponents. I can't simplify with anything with the log base 5 and a number of 5 here, or simplify it that way. So this is my final answer. Okay. Now, if we take a look at this from here to here, notice the m, the log base 5 of m was positive and it ended up in the top. The log base 5 of n was positive and it ended up in the top. And the log base 5 of q was negative out in front and it ended up in the bottom. This pattern will hold. So if there's a positive in front, it goes in the top of the fraction. If there's a negative in front of the log, it goes in the bottom of fraction. Right? So what we have now is a pattern that we can shortcut. So if we take a look at this next one, this log is positive out in front. So I'm going to do log, which means that this is in the numerator, okay, or the top, and then it has this power, which is squared. This is a negative, which means that it's going to end up in the bottom. So we have b, and then the power is the 3 out in front. This is really a negative 1/3, right? So it's negative out in front, so it's going to end up in the bottom, and the power is 1/3. So c to the 1/3. Okay. I checked to see if there's any fractional powers. There are, so I can change that. So this gives us log of a squared b cubed cube root of c. Okay. Now in the past we've said there's no roots in the denominator. In this case with our logs, if you get roots in the denominator, I'm okay if you keep it there, because rationalizing it can get pretty nasty pretty fast. So you can leave it just like this and have this as your final answer. Okay. So same thing here. So pause the video, try this, see if you can come up with your answer using our shortcuts, and let's go from there. Again, it's good to be trying on your own, because watching someone do it and understanding is much easier than you doing it yourself and making sure that you're doing it correctly. Okay. So here we've got the natural log of x. This is positive in front, so we're going to have the natural log of, since it's positive, it goes in the numerator. This is positive, so it goes in the numerator, so of y, and then the sixth is the power. This is negative, so it goes in the denominator, so z to the second. This is negative, so it goes in the denominator, so 16 to the 1/2. Okay. I have a fractional power, so I can simplify that. So this is going to be the natural log of x to the 5th, y to the 6th, z squared, square root of 16. But we know the square root of 16. So I'm going to do the natural log of x to the 5th, y to the 6th, over the square root of 14 is, or sorry, the square root of 16 is 4. So 4z squared. Okay. There's no other simplification that I can do, so this is my final answer here. Now, if we had gone back and looked at one of our front ones, or top ones, not front ones, here, notice both of these are positive, so they're both in the numerator, and then there's nothing in the denominator, so it's really just over 1. So just realize that sometimes you won't necessarily have a denominator that needs to be written. Okay? And that's how we condense our logarithms using those properties.